Good morning, everyone. Welcome to DNS system. Have you ever think about how does internet find websites? Let us say somebody type www.google.com into his browser. How does computer know where Google is? Or let's imagine when you wake up early in the morning and then try to browse Instagram. Do you know how does computer know where the Instagram is? So in order to answer, DNS is like a internet phone book. For human, it's very easy to remember name, whereas computer understand numbers. So DNS connect these two dots. Let's for real life, we remember people name, phone number, and the phone book. So in terms of DNS, person name is like a domain name, phone book is like an IP address, and phone book itself is a DNS server. Have you ever thought about the importance of DNS? Imagine if DNS fail, or without DNS there will be a large impact. The internet would break. We would not be able to view websites. Email delivery system will not function. There would be security issues like phishing, spoofing, and there would be performance issue as well. Imagine for a while, do you like to remember name, for example Google, or you like to remember an IP address 142.250.190 plus dot 40. Obviously the easy task would be to remember name, right? It's very hard to remember internet. I would believe if somebody would say, if you would like to browse Google, type in your browser 142.250.190 plus 114. The total number of the population would be half if we enforce this rule. So it's very easy for people to remember name. They can go to the internet and just type www.google.com, and then very easy to get whatever they needed. So every time you open Instagram, Google, or YouTube, DNS works silently in the background. Today we'll understand how that's invisible system work and why breaking DNS take down the internet. Okay. Real life example. In your phone book, you'd have saved your mom number. You don't, or maybe it's hard for people to remember phone number. The phone automatically find that number. When you just type mom, she'll be listed on the phone book, and then you'll be able to call her, right? So it's a real life example which will be helpful for you to understand how DNS function. So if you look into the technical detail, on the top there's a dot, beneath dot there are top level domain which are called TLDS or CC TLDS, top level domain, .com, .net, .org, .au, .info, .biz, and other CC TLDs. Beneath AU, if the site is organizational, then it could be .org. If the site is commercial, then it could be .com. And under .com, US registry, Microsoft, Google, Yahoo, these are the third level domains which are user defined. It has to be registered in the domain register, and this should be unique. So we don't have control on TLDs and CC TLDs, whereas we have control on the third level domain, which has to register on domain register, and then you can create on your own. If you are doing this function in your internal lab, and if that domain name is only within intranet, then you can register that name in your domain system. All right, so we can say that DNS is a hierarchical decentralized naming system for computer service or any resource connect to internet or private network. It translates human readable domain name into an IP address, which is shown in the figure below, versus the other part shows the file system. For example, there's a C drive, and then there's program file, Windows, temp. These are folders. Beneath Windows, there could be cache, system32, font, media. Inside system32, there could be drivers, DLL, and spools. Domain naming and a directory naming. Domain naming start with dot, and there are top level domain, and beneath top level domain there could be other sub level domains, and so on and so forth, as shown in the figure. Starting point is the root zone, which is a dot, and there are top level domain and country specific top level domains, and beneath those country specific top level domain there would be again commercial, organizational domain, which are called two level domains, and beneath those there are third level domain based on our requirement. Beneath those the hierarchy could goes furthermore, could be internal, pros, and the list goes on. So what is domain? A domain is a subtree of a large tree identified by a domain, contain resource record and subdomains. Some resource record point to authoritative server for subdomain and zone. Root for Australia is .au. So google.com.au is domain name, which is shown here on a picture. All right, so we traverse the tree from bottom to up. Now, in order to understand DNS, we have to understand the DNS resource record. A domain contains resource record. Resource record are analogous to file. These are classified into different types like SOA, NS, A, CNAME, MX. These are all defined in zone files. A means associate. It is the record which map the FQDN into IP address. For example, www.google.com A record 203.18.56.31. So whenever people will browse www.google.com, the DNS will look into its database and map that IP address to map that FQDN to an IP address. CNAME, it's similar, like people have the official name, and then the people would be called with the pet name in their friend circles or maybe in home. Then like people will have a different name, but all those names signifies the same people. We apply the same rule here in DNS. If you want to give multiple name to the domains, we would point it through the CNAME in DNS database as shown in the figure. For example, search CNAME google.com dot. So it's an alias for the domain name. MX is a mail exchanger. Define the mail server for a particular domain. Mail exchanger record hold the name of host and their priorities, and able to delivery for the domain, mail for the domain. So mail is a very important activity. There has to be MX resource record defined in the DNS database so that the mail server can function. NS resource record, it says authoritative names of server for domain. For example, Google would have its own name server, Yahoo would have its own name server, Instagram would have its own name server. So in order to say the name server for domain, we have to define NS resource record into the DNS database server. Now what is zone? It is a record which are held in a database file called zone file and served from an authoritative name server. Zone refer to all the resource recorded in a domain, but its subdomains or could delegate record for other domains. What is name server? Server responsible for answering DNS queries exist at all level of hierarchies. Authoritative name server hold part of the DNS database. One name server can serve more than one zone. Many servers should serve the same zone. Some name server are authoritative for certain zones. Now there are two types of queries in DNS database: iterative and recursive. All right. Serve two very different functions. We should not mix these two. Generally, DNS on your computer point to its recursive. Zone are hosted in iterative name server. Iterative server can only answer information they know or have cached. Recursive query know how to ask other informations. Recursive name server is a DNS server that takes full responsibilities for resolving a domain name and return a final answer to a client. How does it work? Client send one request and the recursion will start from the server. The server will query root DNS server, query top level domain server, queries authoritative name server. So now here DNS server is taking the request on behalf of client and reaching out every possible solutions to get the final answer. So it would be like client would send a request and the recursion would perform from the DNS server to get a final IP address. Iterative name server and iterative name server respond with the best possible information it has, usually referral instead of final answer. So whenever a client asks for a DNS server request, or whenever a client initiate a DNS server request, it will give a best possible answer instead of a final answer. It would refer to a particular DNS server. So server does not fully resolve name. It responds with I don't know the IP, but asks the next server. Client request is sent to a root DNS server. Root would point to the top level domain server, and top level domain server would point to a authoritative name service, DNS service. You can have a look into this picture in order to understand how recursion and how recursive and iterative queries on DNS work. The client sent the query for www.dnsexample.com. The recursive query is sent to a DNS server. It will ask for root server. Since it's a commercial site, the root server will point to the .com top level domain server, and top level domain server would point to the Google authoritative name server, and from there it will get an answer and return the final answer to the client. Whereas in iterative DNS query, a query for www.example.com, it would go to the root server, and the root server will try for .com server and would ask for authoritative DNS server. So the referrer to the next server is sent on each part of the request. Now, when you type www.google.com into a browser, what happens? How does the web page come into your screen? So this would be a high level picture, understanding the journey from browser to the server. It would be like URL. It would go to the DNS server, and DNS server would give an IP address. In order to face that, there has to be a TCP connection via HTTP request, and server would respond to the HTTP response, and the page would render. Let's have a look into the detailed workflow. The first step would be you are parsing. The protocol is HTTP, domain name is google.com, path is / browser understand how and where to connect. Step 2, local cache checking. Browser DNS cache check would perform, or if the operating system has the cache record, it would check the host file. If IP is found, DNS name is skipped. Third, let's say if the answer is not found there, then the DNS resolution query would send to a recursive DNS server. It could be ISP DNS server or whatever DNS server that you have mentioned in your client. And step 4, DNS lookup process will start. It will go to the top root DNS server, find the top level domain, and the top level domain would point to authoritative name server, and the final answer would return, which will be displayed on a browser. For example, www.google.com is pointed to 142.250.190.114. This IP address would be cached for future requests. If other clients send the same request to the DNS server, now the answer will return from the cache. It will not follow the whole process. On step 5, the SYN and SYN ACK would perform three-way handshake here, and the reliable connection is performed since HTTP is a TCP connection. Step 6, HTTP GET request will perform. The host would be google.com and the browser request home page. The server processing, step 7, request hits load balancer nearest data center select, and the server process the request. HTTP OK request would come as 200 OK and HTML content returned to the browser. It could be multiple requests, image, CSS file, JS font. One web page would send multiple requests, many requests. So TL handshake would perform before HTTP if it's an HTTPS connection, and then encrypted communications between client and server would perform. Why does it all matters? Because it helps us to troubleshoot a network related issue. If the performance is going really high, it will help us to analyze that performance issue, as well as it will aid in helping security and security issues as well. So it's really important, to understand each information, how does it flow, and how the function is happening in the background. Summary: DNS is an internal part in most protocol used on internet. Without DNS, internet would not function. It's very easy for human to remember names rather than remembering numbers. It is the largest distributed database system. So remember, it's very easy to remember name rather than a number, right? Similar, like it's very easy to like go check your phone and search for different people on a phone, so you don't have to remember all the names, and it's very difficult. That's where the DNS comes into account. So on a final note, if I have to say what is the function of DNS, then it would perform name resolutions, or to be specific, it resolve FQDN, fully qualified domain name, into IP address, or IP address into the fully qualified domain name. Thank you. Have a good day.